Hello everybody and welcome to your lesson on scientific method. Today we're going to talk about the process that scientists use to solve a problem. Now this should be a review because typically we do scientific method at the beginning of every single science class, so earth science, biology, chemistry, physical science. So it should be a little bit of a review, but if it's not, no worries because I'm going to take you through step by step. So here on our title page, we have a question. It says, hippos do what? And the reason this question is here is because we're going to use a little mnemonic to help us remember the steps of the scientific method. So let's go ahead and move forward. So the mnemonic that we're going to use is really quiet hippos eat dark chocolate. So really quiet hippos eat dark chocolate. And the first letter of each of these words is going to be associated with a step of the scientific method. So R, Q, H, E, D, and C. So I'm going to take you through and tell you what each of those letters represent, which part of the scientific method, and then we'll talk about variables and how to find those as well. So the R stands for research. This is the essential part of the scientific method. This allows scientists to learn about the area or the concept they want to test. It also helps narrow down the choices and allows them to see if there's an area they want to discover or part of the scientific literature they want to refute. Now, research is just looking into the background information of whatever question it is that you're asking, okay? And research, when it's framed this way with this kind of verbiage, research can sound a lot like, looking into scientific articles and looking at academic journals, but research can be as simple as reading the back of, a carton of mouthwash or something like that. So research doesn't have to be intensive. We use the scientific method in our everyday lives without realizing it. So just know that research can be like opening up Google, reading information about something to help you answer a question. The Q is for quiet, which is that question. So all scientific discoveries occurred because someone had a question about the world or the universe. So how do organisms evolve, right? What kind of medicine can help kill this type of bacteria? All those questions help prompt scientists on a journey and using the scientific method that will help them answer that question. So the question is just what kind of problem that a scientist wants to solve, what kind of question they're asking. H is for hypothesis. So this is the educated guess or the prediction that you make based on research. So you ask your question, you do your research, and then you formulate a hypothesis. Typically, your hypothesis is going to be an if-then statement. So if I throw a ball in the air, then it will come back down because gravity is present on Earth. So if you're writing a hypothesis, you should always frame it in that way. So if I do this, then X, Y, or Z will happen. E is for experiment. So this is the doing process. This is the part that you are actually testing your hypothesis. So the experiment needs to be quantifiable, meaning that you can collect data. And that is something that can be measured and also repeated. So if you are going to perform an experiment, you should have a step-by-step process that you do that another scientist could come in, read it exactly the way you perform it, and duplicate the experiment as well. The D is for data. So these are the results you get from the experiment that are then compiled and analyzed. Data could be measurements. They can be displayed in graphs, charts, tables, any kind of way that is appropriate for the type of data that you are collecting. So this is really what you're going to be able to use to kind of identify whether or not your hypothesis was real or not, or true or not, I should say. And then C is your conclusion. So this is where the scientist writes about what was gained from the experiment. So if the hypothesis is true, you're going to talk about the errors that could cause an issue with the data, and it may lead to other questions and experiments as well. So if you get a result that's not quite what you expected, it might prompt you to ask another question or run another experiment. But conclusion is based on your data. So the data that you collect, that you compile into the graphs, the charts, that's going to be your indicator for your conclusion. So you always want to draw a conclusion based on data. because conclusions that you just, you can't come up with a conclusion out of thin air because it needs to be supported for it to be scientifically valid. Okay. So now that we know the steps of the scientific method, we need to talk about the variables. And this is the last thing. We need to be able to identify the different types of variables in an experiment as you're going through the scientific method. So the first variable we're going to talk about is the independent variable. So that's the thing that is manipulated. I always think of this as the thing that I change. So it's what you manipulate about the experiment. The dependent variable is the thing that is changing in response to the independent variable. So it's the thing that you measure. That's the way I always tell my students. It's a really great way to help you quickly identify the dependent variable. If you're reading an experiment, normally in the last couple of sentences, it will tell you what the student or the scientist is trying to measure. So maybe it's plant growth. Whatever you're measuring is going to be your dependent variable. And then the control is the normal conditions. So the normal conditions of your experiment. And what I mean by that, let's say, for example, you are measuring plant growth, and you're going to measure how different amounts of water affect plant growth. So you're going to vary how much water each plant gets, which would be your independent variable. Then you would measure the dependent variable, which would be the plant growth itself, because that's what you're trying to figure out. And then your control would be a plant that gets a normal amount of water under normal conditions. So you always need to have a control that you can compare your results to, because without a control, your scientific data doesn't mean anything, because you have to have a control to be able to compare your results. So let's take a look at this question. I know it says challenge question at the top. It's not. I'm just going to go over and review it with you. It says you want to test a new drug that supposedly prevents sneezing in people allergic to grass. What is the dependent variable? Okay, so here it wants you to identify the dependent variable, basically what is being measured in this experiment. So we're testing a drug that prevents sneezing in people allergic to grass. So if we want to understand if this drug prevents sneezing, our dependent variable is going just to be the amount of sneezing that the people in the experiment do, because that's what we're trying to measure. We're trying to measure if the drug prevents the sneezing, and in order to do that, we would measure how much sneezing the people are doing when they take the drug. So the dependent variable, being what you measure, is going to be the amount of sneezing that the people do. Now let's do one more and see if we can identify the independent variable. It says you want to see if playing music makes plants grow taller. What is the independent variable in this experiment? Well, we're not given a lot of information, but we can kind of make some conjectures about this. So we want to test and see if playing music, so different types of music, can make plants grow taller. Well, if we're measuring the plant growth, that would be our dependent variable. So our dependent variable here is going to be the plant growth, because that's what we're measuring. That's what we want to see if music has an effect. So if the plant growth is the dependent variable, that means the variable that I am manipulating or I am changing, remember the independent variable is the thing that I change, is going to be the music in this instance. Okay, so the type of music, it doesn't say specifically if it's like the volume of music or the type of music, but the music itself would be the independent variable because that's what's being manipulated. And again, here, the plant growth would be the dependent variable because that's what we're measuring. You guys are going to do some examples where you go through and identify the dependent, independent, and the control today using some scenarios from The Simpsons, like the cartoon The Simpsons. But I'm going to post a video where I go through and I do the first example with you. So if you're still confused about independent and dependent variable, go into your evaluate portion today, and there'll be another video there where I go through step by step in one of those scenarios to help you work on your assignment today. And if you still have questions, of course, shoot me an email and I can definitely help you. Hope you guys have a great day, and I'll see you next time.